For the last few episodes, retrieval has slowly been growing up. It started as one fixed lookup, then we made the chunks cleaner, added a re-ranker, and even swapped the whole structure for a knowledge graph when the question demanded it. But notice the thing all of those still have in common. They fetch once. The system decides in advance how to retrieve, runs that single pass, and then the model has to answer with whatever came back, good or bad. And that is fine right up until the moment the first fetch is not enough. So the natural next step, the one GraphRAG left us pointing at, is to stop deciding retrieval in advance and let the model run the search itself. Look at what it got, judge whether it is actually enough, and go again if it is not. When retrieval becomes a loop the model controls, you have Agentic RAG. Quick note before we dig in. If you find this useful, subscribe and drop a topic you want explained in the comments. Now let us get into it. Here's the whole idea in one sentence. Agentic RAG is retrieval augmented generation, where the model no longer does a single fixed lookup, but runs retrieval inside a loop it controls, planning the query, retrieving, grading whether the results are good enough, and reformulating and searching again when they are not, before it ever writes an answer. To feel why you would want that, look at where the one-shot version quietly breaks. Static RAG fails in 3 specific ways, and they all trace back to that single fetch. The first is the ambiguous question. Ask something vague, like how do I fix the slow query, and a one-pass system embeds those exact words and grabs whatever looks similar, with no chance to ask which query or which database. The second is the multi-hop question we met with graphs, where the answer is a chain across documents. One retrieval pulls the first fact, but has no second turn to go get the next one. And the third is the deepest insufficiency. Sometimes the top passages are simply not enough to answer, and a static pipeline has no way to notice that because it never checks. It just hands the model thin evidence and lets it fill the gap with a confident guess. In every case, the flaw is the same. There is no second look. The fix has 2 moving parts, and the first is query planning. Before it retrieves, an agentic system can reason about the question and reshape it. A vague query gets sharpened, and a big multi-part question gets decomposed, broken into smaller sub-questions that each get their own retrieval, whose answers are then combined. Compare the founder backgrounds of these 3 startups becomes 3 separate lookups, one per company, instead of one hopeless search for a passage that compares all 3 at once. The model is now writing its own search strategy rather than passing your raw words straight to the database. But the real heart of Agentic RAG is the second part, the self-correction loop, and it is worth walking one full turn. The model retrieves some passages. Then, crucially, it grades them. It asks, are these actually relevant to the question, and taken together, are they enough to answer it? This grading step is the whole difference because it is the moment the system gets to be honest about what it found. If the passages pass, it writes the answer, and even then, it can check that answer for faithfulness. Does every claim actually trace back to a retrieved source before letting it through? But if the grade comes back weak, it does not just surrender an answer anyway. It reformulates, rewrites the query, or picks a different source and retrieves again, looping until the evidence is genuinely good enough or it hits a stop. Retrieve, grade, reformulate, retrieve again, then answer. That loop is the entire point. And once the model is running the search, it can also route. Not every question should hit the same place. A question about last quarter's numbers belongs in the SQL database, a question about company policy belongs in the document store, and a question about today's news belongs on a live web search. An agentic system can look at the question first and send it to the right source, or even skip retrieval entirely when it already knows the answer, instead of blindly retrieving for everything. Choosing where to look is just as much a decision as choosing whether to look again. Let me name the real work here because this is not hand-waving. Self-RAG, from a 2023 paper, trains the model to emit special reflection tokens that let it decide, mid-generation, whether to retrieve and whether its own output is actually supported by what it found. And it cut hallucination on its benchmarks sharply compared to same-size baselines. Corrective RAG, or CRAG, takes a lighter, model-agnostic route, adding a grader that scores each retrieved chunk and, when the evidence looks weak, automatically falls back to a web search to fill the gap before generating. And in practice, you build these loops with frameworks we are about to meet. In LangGraph, the grader is a literal node in a graph with a conditional edge that routes back to retrieve or forward to answer, and in LlamaIndex, agentic query pipelines wire the same planning and re-retrieval into a reusable flow. The pattern has a name and real tools behind it. Now the honest trade-off, because this power is not free. A static RAG query is one retrieval and one generation. An agentic one might plan, retrieve, grade, reformulate, and retrieve again several times before it answers, and every one of those extra steps is more model calls. Expect it to burn something like 3 to 10 times the tokens and run 2 to 5 times slower than a single pass, sometimes more. So the rule of thumb is the same shape as it was for graphs. Do not reach for Agentic RAG when a single lookup already answers your user's questions. Reach for it when the questions are genuinely hard, ambiguous, multi-hop, or the kind where being confidently wrong is expensive, and the extra cost buys you an answer the one-shot version simply could not reach. So, how does this land depending on who you are? As an individual, you have already watched it happen. In the research tools that visibly search, read what came back, decide it is not enough, and search again before they answer. That back and forth is this loop turning. As a startup, the advice holds. Start with plain RAG and add the grading and re-retrieval loop only on the specific hard questions where your users keep getting let down because you pay for every extra turn. And as a large enterprise, this is where accuracy is worth real money. A system that can admit its evidence is thin and go look again instead of confidently making something up is exactly what you want anywhere. A wrong answer carries a cost. So let us bring it home. Static RAG fetches once and answers no matter what, which breaks on ambiguous, multi-hop, and insufficient context questions. Agentic RAG fixes that by putting retrieval inside a loop the model runs, planning and decomposing the query, grading whether the results are relevant and enough, reformulating and searching again when they are not, and routing to the right source at the real cost of more tokens and more time, with methods like self-RAG and CRAG and frameworks like LangGraph and LlamaIndex making it concrete. But notice what just happened to retrieval. It became a loop. Think, act, look at the result, decide whether to go again. That is not a retrieval idea at all. It is the shape of something much bigger. Retrieval was just the first place we watched a model take control of its own steps. In the next episode, we pull that loop out of retrieval entirely and look at it head-on, the think, act, observe, repeat cycle that turns a language model into an agent. Content. Invoke that is the core of it. If this helped, hit like and subscribe. Ring the bell for the next deep dive and tell me in the comments what you want broken down next. Thanks for watching.